Let us derive Prism formula. For that, consider ABC is the principal section of the prism, where BC is the base of the prism, AB is the refracting face of the prism, and AC is also refracting face of the prism. Consider PQ is the monochromatic light which is incident on the face AB. When it incident on the face AB, it moves from rarer medium to denser medium. Therefore, it moves toward the normal. Here, MD is the normal to the face AB. And refraction takes place, where R1 is the angle of refraction and R is the incident angle. QR is a refracted ray. It gets again refracted at the point R, and when it moves from denser medium to rarer medium, it moves away from the normal, because here ND is the normal to the face AC. We can say that PQ is the incident ray, QR is the refracted ray, RS is the emergent ray. I is the angle of incidence, R1 and R2 are the angle of refraction, E is the angle of emergence. Also, A is the angle of prism. Now, PQ is produced to QP dash and RS is produced back as Rx, and the angle between the incident ray and the emergent ray is called as a delta. That is the angle of deviation. Angle of deviation, delta. We have to find out this value of delta. Now consider angle MQP is angle I, and opposite to angle MQP there is angle XQD. Therefore, this XQD becomes angle of incidence I, because both these angles are opposite. As both these angles are opposite, this angle XQR we can write down as I minus R1. Similar way, angle NRS and angle XRD are opposite angles. Therefore, angle XRQ can also be written as E minus R2. Now consider a triangle. XQR, we can write in a triangle XQR, addition of these two angles is equal to delta by the exterior angle theorem. Means we can write here angle XQR plus angle XRQ is equal to angle P dash XR. Therefore, putting the values of this angle, we can write I minus R1 plus E minus R2 is equal to delta. We can rearrange this equation. How we will write here? I plus E minus R1 minus R2 equal to delta. We can write I plus E minus into bracket R1 plus R2, that is equal to delta. Call this equation as 1. Again I am repeating up to equation 1. Here angle MQP and angle XQD are opposite angle. Therefore, we can write angle XQR is equal to I minus R1. Similar way, angle NRS and XRD are opposite to each other. Therefore, as this angle is E, this total angle is E. And angle XRQ can be written as E minus R2. Then from the triangle XQR, we can write angle XQR plus angle XRQ is equal to P dash XR by the exterior angle theorem. Putting this value, we will write R minus R1 plus E minus R2 is equal to delta. Therefore, I plus E minus R1 minus R2 is equal to delta. I plus E, negative sign is taken outside of the bracket. We will write minus R1 plus R2 is equal to delta. We call this equation as 1. Now, we have to find out the value of R1 plus R2. Now, consider AQDR rectangle means AQDRA. Now consider triangle QDR. In triangle QDR, angle R1 plus angle R2 plus this angle QDR equal to 180 degree. R1 plus R2 plus angle QDR equal to 180 degree. Now consider MN is normal to AB. Therefore, this is perpendicular. Means at this angle AQD is 90 degree. Similar way, ND is normal to the face AC. Therefore, this is perpendicular and therefore angle ARD is also perpendicular. And in cyclic quadrilateral, as these two angles are perpendicular, means angle AQD and angle ARD are perpendicular, means addition of both is 180 degree. Therefore, addition of angle A and angle QDR should be 180 degree. Means in this cyclic quadrilateral, we can write in cyclic quadrilateral, A angle plus this angle means QDR, angle QDR is equal to 180 degree. Observe both this equation. 180 degree is same to the right hand side and QDR and angle QDR is also same. Therefore, we can write here angle A should be equal to R1 plus R2. Call this equation as second. I again repeat all this. In triangle QDR, angle R1 plus angle R2 plus this angle QDR is equal to 180 degree. Now see, MD is normal to AB. Therefore, this angle AQD is 90 degree. Angle, similar way, angle ARD is 90 degree. Means addition of both these angle, we can get 180 degree. Therefore, angle A is added with the angle QDR should be 180 degree. Means AQDR is a cyclic quadrilateral. We can write in cyclic quadrilateral AQDR, angle A plus angle QDR equal to 180 degree. Equating both this equation, we will get A is equal to R1 plus R2. Put this value in equation 1. What we will write? I plus E minus A is equal to delta. Therefore, we will write here I plus E is equal to this minus A. At the right hand side, we will write here A plus delta. And this is the relation between the angle involved in the refraction of monochromatic light. We call this equation as 3. I is the angle of incidence, E is the angle of emergence, A is the angle of prism, and delta is the angle of deviation. I plus E equal to A plus delta. Now, as I is increased, what happened? Delta decreases at first, and as we go on increasing the angle of incidence, angle of deviation go on increasing. Now see, if we plot the graph, what we will observe here? Practically, it is observed that, see, this is the delta, angle of deviation is taken along y-axis and angle of incidence is taken along the x-axis. Practically, it is observed that as we go on increasing the angle of incidence, at first angle of deviation go on decreasing. Like the graph I am showing. See here, as we go on increasing angle of incidence, angle of deviation go on decreasing, and again as we go on increasing angle of incidence, angle of deviation go on increasing. As we increase the angle of incidence, angle of deviation decreases. It reaches to minimum value, and again as we go on increasing angle of incidence, angle of deviation increases. Now, from this graph, we can observe that if we plot here the line which is perpendicular to the curve, and again we will take perpendicular on x-axis. Now see, this is the value delta, and for the delta we will get two values of angle of incidence. For the same delta, we get two different values of angle of incidence, but there is one minimum value, that is the delta m. For that, here we get the one value of angle of incidence, that is the delta m, that is equal to, at this point I is equal to E. Here the minimum value of angle of deviation, that is called as a angle of minimum deviation, and it is denoted by delta m. When minimum deviation position is reached, at that point we get angle of incidence is equal to angle of emergence. And when this happens, ray PR is parallel to the base BC. Again, I am going to repeat all this. If we plot the graph of angle of deviation versus angle of incidence, what happened? As we go on increasing the angle of incidence, then angle of deviation go on decreasing. It reaches to minimum value, and again we go on increasing the angle of incidence, angle of deviation also go on increasing. The minimum value of deviation is called as the angle of minimum deviation, that is denoted by delta m. Here on the graph, for one delta we will get two angle of incidence, but at the delta m, that is the minimum deviation position, we will get angle of incidence is equal to angle of emergence. And here delta m is the angle of minimum deviation. Minimum deviation condition is obtained when this refracted ray, that is QR, is parallel to BC. Now we can write here at delta equal to delta m, I is equal to E, I is equal to E. Also R1 is equal to R2 is equal to R. We can say here R1 is equal to R2 is equal to R. Put this value in this equation, what we will get? I plus E is equal to A plus delta. Here instead of E, I will put I, means we will write here equation 3 becomes I plus I is equal to A plus delta m. Therefore, twice I is equal to A plus delta m. Therefore, I is equal to A plus delta m divided by 2. This is the value of I. Similar way, we have to find out value of R. Consider this equation second. Then equation second becomes A is equal to, instead of R1 and R2, we will put R, means R plus R. Therefore, twice R is equal to A. We will write here R is equal to A by 2. And here I is equal to A plus delta m divided by 2. According to Snell's law, we will write here diffractive index n is equal to sin I upon sin R. Putting here value, what we will get? Sin I, value of, call this equation as 4, call this equation as 5. Putting this value of I and R in this equation or in the formula of refractive index, we will write sin A plus delta m divided by 2 upon sine A by 2. And this is the Prism formula. This formula is very important. In the examination, two types of questions are asked on this topic. First question is that the relation between the angles involved, that is I plus E is equal to A plus delta. The question is like this: prove I plus E is equal to A plus delta, where symbols have their usual meanings. And you have to write all this in a step, all this up to equation 3 stepwise. And second question is asked such as derive the Prism formula. For deriving Prism formula, you have to write all these and also the variation of the graph, and also you have to write up to this point n is equal to sine A plus delta m upon 2 upon sine A by 2. Now we study next topic, that is the thin prism. At first, we will see what is thin prism. Prism having very small refracting angle is called as a thin prism. Here, when the two refracting surfaces of the prism, suppose these are the two refracting surfaces of the prism, and this angle between two surfaces is less means less than 10 degree, then we can say that prism is a thin prism. Means angle should be less than 10 degree. Then that prism will be called as a thin prism. We know the formula for the prism. N is equal to sine A plus delta m upon 2 upon sine A by 2. And we also know that we can write sine theta is approximately equal to theta if theta is expressed in a radian. Therefore, this sine A plus delta m by 2 is directly written as A plus delta m by 2, and sine A by 2 is written as A by 2. We will write then next step. When this theta is small, we will write sine theta is direct approximately equal to theta when theta is expressed in a radian. We will write here n is equal to, instead of this sine A plus delta m by 2, we will directly write A plus delta m divided by 2 upon sine sine A by 2 is written as A by 2. Here what will get? Next step, A plus delta m divided by A. To add the denominator will get cancelled. N is equal to A plus delta m upon A. Rearranging this equation, we will find deviation for the thin prism. We will write here N into A is equal to A plus delta m. Therefore, N A minus A is equal to delta m. As this delta is very small, we can drop this suffix. We will directly write here delta. And taking a common, we will write a into bracket n minus 1. Therefore, delta, that is the deviation for thin prism, we will write a into bracket n minus 1, where n is the refractive index of the thin prism, a is the angle of the prism, and delta is the deviation for thin prism. That deviation depends upon the angle of the prism, and refractive index means that is the material of the prism. Now we solve numericals on the prism formula and thin prism. Consider a problem. I am writing here problem. You can write simultaneously with me. Write down problem. Find the angle of minimum deviation. Find the angle of minimum deviation for an equilateral prism having refractive index refracting index Now we see example. Find the angle of minimum deviation for an equilateral prism made of material of refractive index 1.732. What is the angle of incidence for this deviation? At first we will write down given terms. What are the given terms here? In this problem, it is given that equilateral prism having angle of prism A is equal to 60 degree, because equilateral triangle having each angle as a 60 degree, therefore equilateral prism having angle A is equal to 60 degree, and refractive index is given to us. We will write n is equal to 1.732. What is this value? This value is nothing but the value of root 3. Okay, what we have to find out? To find the angle of minimum deviation means we have to find out delta m. Also, what is the angle of incidence for this deviation means we have to find out angle of incidence also. For this, we will use formula. What is the formula? Formula of prism n is equal to sine a plus delta m divided by 2 upon sine a by 2. Putting here values, we will solve. What is the value of n? Root 3 is equal to sine 60 plus delta m divided by 2. divided by sine 60 upon 2. Therefore, root 3 equal to sine 60 plus delta m divided by 2 upon sine 30 degree. Again, taking this sine 30 degree to the left hand side, we will write here root 3 sine 30 is equal to sine 60 plus delta m divided by 2. What is sine 30? Sine value of sine 30 is 1 by 2. Write down here root 3 by 2 is equal to sine 60 plus delta m upon 2. We have to find out the value. This is sine 60 plus delta m upon 2. And what is this root 3 by 2? Root 3 by 2 is the value of sine 60 degree. Therefore, we will write here sine 60 degree is equal to sine 60 plus delta m divided by 2. Sine 60 is equal to sine 60 plus delta m upon 2. Therefore, we can directly write here 60, equating both these angles of sine. 60 equal to 60 plus delta m divided by 2. Therefore, we have to find out delta m, means 120 is equal to 60 plus delta m. You will write delta m is equal to 120 minus 60, that is equal to 60 degree. Value of delta m is equal to 60 degree. Again, we know that sine a plus delta upon 2 means this is sine I. Therefore, we will write I is equal to a plus delta m divided by 2. Put your value of a. What is the value of a? 60 plus delta m is also 60 upon 2. You will get here 120 divided by 2, that is equal to 60 degree. This value of I, you will get 60 degree. Read this example. A thin hollow prism of refracting angle 3 degree filled with water gives a deviation of 1 degree. What is the refractive index of water? What is given in this problem? A thin hollow prism of refracting angle. A is given to us. What is given to us? Refracting angle. A is equal to 3 degree. Also, filled with the water gives a deviation. Delta is given. Delta is equal to 1 degree. What we have to find? We have to find out refractive index of water, that is n is equal to question mark. What is the formula for deviation for the thin prism? Because angle of prism is 3 degree, we will use formula delta is equal to a into bracket n minus 1, where n is the refractive index for water. Putting here value, we will write 1 is equal to 3 into bracket n minus 1. Therefore, 1 by 3 is equal to n for water minus 1. 1 by 3 is, we will divide here, we will get 0.33. Recurring value we will get here, that is equal to nw minus 1. Therefore, 0.33 plus 1 is equal to refractive index for water. We will write here, therefore, refractive index for water is equal to 1.33. As it is a refractive index, there is no unit. Okay.